Hello everyone, and welcome to the Innovation Tech Community. And I'm Pratap Reddy, uh, Azure AI MVP. And so today I'm hosting for the Global AI Summer Bootcamp. Today, along with me, Sakshi and Kushbu. And hi Sakshi, hi Kushbu. How are you all?
Yeah, hi Pratap. Yeah,
Yeah,
fine. How are
so
you?
yeah, I'm doing good too. And so today we have to learn some new concepts about this Azure machine learning and more insights from the Sakshi and as well as Kushbu. I think Sakshi is recently got the Microsoft AMVP. And I would like to express the sincere gratitude to her. Say congratulations to you, Sakshi. And I would
Yeah,
like
thank
to,
you.
yeah, yeah. And Kushbu, I think you're the gold MLS. I think so. I saw your profile in the LinkedIn as well, and congratulations to you as well. And today, so I think 200 plus registrations for this particular event, and in this LinkedIn, and as well as 300 more registrations in the some other platforms as well. So I will bring all the audience to this one, and so everything I think everything is ready to go ahead, Sakshi.
Yeah,
Yeah. So the stage is yours, and let's get started, Sakshi. Yeah. So I would like to share your screen, and then you can get started.
sure. So thank you, Pratap, for giving me this opportunity to the speaker this event. So to the session, Azure machine learning. So let's get started. So the contents that I'll be going to cover in this is the introduction to Azure ML, then the need to use Azure machine learning, advantages, the workflow, and then we'll have a hands-on on Microsoft Machine Learning Studio. So Azure Machine Learning, it is a cloud-based platform provided by Microsoft that enables developers as well as the data scientists to like say build, train or deploy as well as manage the machine learning models at large scale. It offers a wide range of tools and services to support the end-to-end machine learning life cycles from data preparation to model deployment and monitoring, etc. Its core machine learning facilitates the development of predictive analysis as well as machine learning solutions. So there are a few key features of Azure machine learning. Like the first one is data preparation, the tools for data cleaning, transformation, and the feature engineering to prepare the data sets for modeling. The second one is the model development. So it supports or various machine learning algorithms and frameworks, allowing the users to build as well as train the models using familiar programming languages like R, Python, etc. So to move ahead, the next one is experimentation. It's a platform for designing and conducting machine learning experiments to compare different algorithms, hyperparameters, and data processing techniques, etc. So can perform algorithm and data processing techniques same. So the next is model deployment. So options to deploy the trained models such as web services or containers, making them accessible for real-time predictions or batch processing. The scalability, it's the ability to scale the machine learning workload seamlessly to handle large data set and complex computations throughout the model building process. And the final is the monitoring as well as the management. Like these are the tools for monitoring model performance, tracking usage metrics, and managing the life cycles of deployed models, including retaining and updation as needed by the user. So let's understand what's the need to use Azure machine learning. So the need for Azure machine learning arises from the growing demand of the harnessing power machine learning and artificial intelligence to solve complex problems as well as drive innovation across the industries. So the main reason, here are some of the key reasons why one should use Azure machine learning. Like in today's high technical world, organization need tools and technologies to extract valuable insights from the data that they provide. Correct. So, Azure machine learning enables the business to build predictive models that can analyze the data and make informed decisions, like leading to improved efficiency, productivity, scalability, as well as competitiveness. To move forward with the scalability, like traditional on-premises machine learning environments, we know that it often lacks the scalability to handle the large data sets as well as complex computations. So Azure machine learning leverages the scalability of the cloud, allowing the organizational scale their machine learning workloads as needed without any additional infrastructure or investment. The most important is the time to value. Like Azure machine learning accelerates the development as well as deployment of the machine learning models by providing a suite of tools and services that streamline the entire machine learning lifecycle, or we can say entire machine learning model building lifecycle. So this reduces the time and effort required to go from the raw data or the unlabeled data to the actionable insights. So it enables the organization to realize the value of the data more efficiently and more quickly. The next one is to access the advanced capabilities. Like we know that Azure Machine Learning offers access to advanced machine learning algorithms, frameworks, and tools that enables the organization to tackle with a wide range of machine learning tasks, more complex computation tasks, right from classification, regression to clustering and anomaly detection, etc. So this enables the organization to address complex problems that may be beyond the capabilities of traditional analytics tools that are available. Um, the next one is the cost effectiveness. Like by leveraging the pay as you go price model of the Azure machine learning, organization can avoid the upfront cost of associated with the building and maintenance of on-premises machine learning infrastructure. So this makes the machine learning more accessible to the organization of different sizes, including the starter right from the startups till multinational companies. The next one is integration with existing system. So Azure Machine Learning integrates with other Azure services and the existing IT infrastructure that are available. So thereby making it easy for the organization to incorporate machine learning capabilities into their existing workflows and applications. This also enables the organization to leverage the existing investments in the technology and infrastructure while adding the powered capabilities by machine learning. And last but not the least is the security as well as compliance. So Azure Machine Learning provides a robust security and compliance features, including data encryption, access controls, compliance certifications to ensure that sensitive data is being protected and regulated requirements are met. So this is particularly important for industries such as healthcare, finance, or government industries where the data privacy and security are paramount. Yeah. So So this is the workflow of how Azure Machine Learning Services works. So the first one, it's the Azure Machine Learning Service workflow. Here is it's a three-step process basically. So the first process is to prepare the data. The second one is experimentation, which includes the building, training, as well as testing the model. And the third one is deployment. So before we start with collecting and processing our data, we basically need a workspace where we can perform all the operations. A workspace represents the highest level of centralized resource of a machine learning service. It holds the list of all compute targets used for targeting deployed models as well as the developed models. So it stores the log of training execution, metrics, output, as well as snapshots. The data assists in choosing the best training model for the project also. So the model that is registered to the workspace. So is the preparation of the data, that this is the first step in creation of the machine learning models, which includes collection as well as the processing of the data from the data store as well as the data set that we have used. So like we all know that data, what are data stores? So the data stores used to store the connection information of Azure storage services, which can be referred to by name or are attached to the workspace. Like some examples of the Azure data storage stores are Azure Data Lake or Azure SQL database, Databricks file system, etc. And to talk about dataset, the dataset is a reference to the data in the data store or behind a public web URL, and also it creates a copy of its metadata. So there are two types of datasets that are supported by Azure, that is namely file dataset as well as tabular dataset. The next one is experimentation part. This is the second phase of the workflow of Azure machine learning model building. So after the data is registered and stored in the dataset, the next step here comes is to build, train, and as well as test our build model. So to understand the keywords, let's start with what is a model. So it's a piece of code that takes input as well as and it produces the output for the given inputs. So while deploy a machine learning model, it requires selecting an algorithm, availing data, tuning of hyperparameters, etc. Training also includes an iterative process that provides a training model narrating what is learned from the training process. The model is obtained by executing in Azure Machine Learning. The next one is the compute targets. So compute targets is a machine or a set of machines that are used to run training scripts or host service deployments. A local machine or a remote compute resource can also be used as a compute target. The compute resources used for compute targets are attached to the workspace. So there are basically four types of compute targets. That is, the first one is the local computer. So local computer, it is a computing context, we can say, where the experiment submission code runs. The second one is the compute cluster. So we can refer to it as it is a virtual cluster, we can say, managed by Azure Machine Learning. The third one is the interface cluster. So it is a container based development target. The fourth one is attached compute. So it basically includes Azure Databricks, Azure Data Analytics, etc. The third one is the deployment part. So once the model is trained and tested, it is stored in the model registry and then deployed in the web service or IoT modules. So here it provides an environment to deploy the model independently, consisting of components required by the model. So it also contains an image which contains a model, application, or a script and dependencies required by the model or the script, we can say. So the images are stored in the image registry. There are two different types of images that are supported. The first one is FPGA image. It is used while deploying a field programmable gateway array in Azure Machine Learning. It's a semiconductor device used in electronic circuits. And the second one is the Docker image, which is used to deploy computer targets such as Azure Kubernetes services or Azure container instances. So the registered model that is deployed as a service and endpoint, it instantiates the image into a web service that is further hosted over the cloud or into an IoT module for using as it is in the integrated device deployment. Yeah, so here we come towards the hands-on, like we are presenting a hands-on session on Microsoft Machine Learning Studio. So basically, let's understand what is Microsoft ML Studio. So it is a cloud-based integrated development environment ID for building as well as deploying machine learning models. It offers a user-friendly interface that allows the data scientists as well as the developers like us to create, train, and develop machine learning model solutions without requiring extensive programming knowledge. So let's have a quick overview. Like the first one is the drag and drop interface. So ML Studio, it provides a drag and drop interface for building and machine learning model, making it easy for the user to create the workflow without writing explicit coding or without writing any single piece of code, you can say. So user can select from a variety of pre-built modules for data processing, feature engineering, model training, and evaluation, and connect them together to create some custom pipelines. The next feature is the pre-built algorithms in Microsoft Machine Learning Studio. So it includes a wide range of pre-built machine learning algorithms and techniques such as classification, regression, clustering, etc., and many other machine learning algorithms, uh, including anomaly detection, etc. The algorithms that are optimized for performance and scalability that allow the users to train the model on large data sets and with a greater efficiency. The next one is the custom modules. It's the next feature. So in addition to the pre-built modules, ML Studio also allows the user to create custom modules using Python as well as R coding. It supports both Python as well as R. This enables the users to incorporate their own algorithms, data processing techniques, and external libraries into the machine learning workflows. To move further, the next one is the experimentation as well as versioning feature. So, Machine Learning Studio provides tools for designing as well as conducting machine learning experiments, allowing the users to compare different algorithms, hyperparameters, and data processing techniques. Users can track and version their experiments to reproduce the results and collaborate with the team members. And last but not the least are the scalability and performance. So Machine Learning Studio also leverages the scalability and performance of Microsoft Azure, allowing the user to train and deploy machine learning models at a large scale. So users can take the advantage of Azure's powerful computing resources to handle the large datasets and complex workloads efficiently. The next one, it's the deployment options. ML Studio also offers multiple deployment options for the deploying trained models, including web services, batch scoring, and integration with Azure services such as Azure Function, Azure Data Factory, etc. This also enables the user to integrate machine learning capabilities into their existing applications and workflow seamlessly. And the it also provides a tool for monitoring as well as managing the model's performance, tracking the usage metrics, and managing the life cycle of the deployed models. User can also monitor model accuracy, performance metrics, and resource utilization to ensure that the model are performing optimally and the business requirements are being satisfied. So here I would like to hand over the screen to Khushbu to continue further with the event. Yeah, thank you.
Hello, Sakshi, may I start now?
Yeah, yeah.
Okay. So, as Sakshi tells about that, what is a machine learning studio of a Microsoft, which is a Microsoft application, which is basically worked upon a drag and drop functionality and some additional, we can say, flow, which I want to tell that how we can start and what we can do in this like next session. Then first is that just go through the process, like what we have to do and what we are going to do in that hands-on session. First we have to sign in like Azure Machine Learning Studio, and then create a new account, like if anyone want to do work at that studio. And beside it we have to create new experiment. And then like anyone make their experiment name of anything, like any name we can give it to. And then select a target, like choose the compute target where we want to like experiment run, so that connect from available options such as local computer or ml compute as well. And then we have to add modules like drag and drop module, and which we can see from the left panel of HR Studio onto the experiment canvas, because it give a functionality to drag and drop to define the workflow. And then we connect, we after it we will do connect module to each other, connect the module on the canvas to define the flow of data and operation, like how is data is going, how our project is working. So use arrows to connect the output of the one module to the input of the another. And after that, the other step is configure module, like double click on each module to configure its setting. And then we can run our experiment, monitor our execution, and review the result. So basically it's the flow on which we are going to now hands on at Microsoft Studio. So I'm just presenting my screen.
Kushbu, are you going to share your screen?
Yes.
I didn't find any screen here.
uh, 1 minute, 1 minute. Yes. Is this showing now?
Let me check. Yeah, yeah,
Okay.
please.
So, yeah. So, basically, this is the experiment which I am going to tell about this. Like, that's the, we can say, UI of Microsoft Machine Learning Studio. There are many feature like project. This is we can click on that. This is experiment web service dataset train model, and this is setting. So we are now create our own experiment on it, so that we can understand that how this machine learning studio worked upon a pre-built data set, pre-built as Sakshi said about the pre-built algorithm like a clustering and other. We can apply directly by just a drag and drop feature, and we have no need to any type of coding in this our experiment which is we are going to execute. So we have to just for start this experiment, you have to just click on new and then click on the blank experiment, and then it will start. So this is my experiment which is I am going to tell about you that what we have done in this. Mm, so basically first of all we have to take a data set. So here in this left panel you can select your data set. Yeah, so here are many type of like it's a sample save data set. So I drag from here adult census income data set. You can also take like this is a our adult census income binary data set. And then after that we have take a column, and from take a column you can use here manipulation in this left panel manipulation, and then select column and just drag and drop here like this. Okay, but we are already, so we are not going to do this again. Then select column in data set, and then we have to split data like how a machine learning model work. We have a very well we have to know that first is we have a data set, after it we have to apply in column. And for make the data set you can also see on click here, and you can also visualize this data set like what are in this data set. Like there is a age, work class, and then this is all column like it's about tell about the education like a bachelor, 11th, anything, ninth, master. It's about the education number, and this is marital status, occupation, relationship, and this is race, and this is capital less capital loss and all about, and this is income. So basically what we are doing to, and this data set name is adult census income binary classification data set. Okay, in this we can see that the row is 32,000 almost and column is 15. So from here we can also easily visualize that on which data we are working upon. And then we have to select the column in our data set. So for do this, in right panel you have see that I have selected it's sorry, it's not telling about the which yeah, in this box you can say that my column selected is age, work class, occupation, and then income. You can easily like you can launch column generator and then select your column like this. Okay, and then it's not, and then it's the arrow and you can go ahead. So basically now we can see how many column we have age, work class, occupation, income, and relationship. It's our as column, and to execute it you we have to just add it to arrow. Like you have to do this drag and drop and then add it by this column feature. Okay, you can also download this and generate that code which is behind this drag and drop functionality. Also you can also understand and get that code also. And then we have split data. So in left panel you have to write split data. Okay, this is a split data. You can easily drag and drop like this. And then like firstly I have just wanna tell about that. You have to just first drag and drop all the feature like select column, then split data. In machine learning model we have a data set, we have ensured the column, now we have to split. And in ML we giving a split data set in like this, that we split data in a true set, training set, and testing set. And we have a testing set is 0.8, which is I am fraction of row. Like I have take 0.8, we can say 80% rows for the testing and rest is for training. So after that data is split, we will give it to our train model. And then train model, it's also a drag and drop. You can train model, sorry, you can take from here. Okay, you can take from here and connect this arrow to this. Like a split data have two endpoint, because first is for testing data set and other is for training data set and connected to train model. And yeah, this is a two class boosted decision. This is a basically algorithm which is we are using in our project. Beside it, you can also write that classification. And there are various type of classification model, which is it showing like a multi-class one as all two class average. So I am using two class boosted decision algorithm because it is finally and properly work upon a data set which is a binary type of data set. And then we connect this arrow to train model, because flow is going like this. Like first is we have a data set, then we have select the column, like how many column we want to take for generate the income of a individual. Okay, based on the column data, like there are income, sorry, occupation and age, class, etc. And then we split the data. After it, you we have just drag and drop score model and evaluate model. Okay, just the basic simple project which from which we can easily understand that what is happening in Microsoft Azure Studio, how it's work. And then it's our evaluate model. Okay, you can easily write here in the left panel, um, score model. Okay, score model is here, and then evaluate model. This is evaluate model, and just drag and drop here and connect it like this, because if we have two endpoint, then we have to connect it to boxes, as we can see here. And after it, you have to save your model and then run. So it's showing the experiment properties, start time, end time, status code, and status detail. So it's running in my machine. You can see flow like this. Okay, split data, and for your there is a zooming option also, but huh, domain run. Yeah, so it's showing the status code is finished. It means that art model worked finally properly. Okay, if there is a mistake, there is any type of mistake, then this status code showing failed here. Okay, so to see in the right panel, we can easily understand that our work done is or not, our model is working properly or not. And then after it, we have other option like also, like there are many feature you can see, like run history, save as, and this is a setup web service. Setup web service, we can also use update predictive experiment on our model. So after it, like I have to do, yeah, so it's creating a predictive experiment on our model which is already run. Okay, so this is now we can deploy our web service from here. So your edit can be validate. Now on, we have our this data and various other column. So basically, it's showing an error about on what. It's status detail requested on this data. So it's the model which is log. It's like the same model. First it's showing finished and other is showing failed. Yeah. So this is working properly. We can see a right arrow section in here. This is a web service and you can easily deploy web service. So how this model or work on predictive experiment also. And if you want to create any project, you can also create your project like I am doing this, and you can also create your new project from here like empathy project. And then you can give anything like I gave ml again. And then add asset to it. Add asset like it's showing various type of data set, restaurant customer data and restaurant rating with the data set. And this is an experiment. It's my experiment. This is the module. It's not have any module. And you can also like all the asset which you can add to your project. Web service, train model, experiment created. It's showing my experiment which I have recently done. And this is our dataset section. And I am not previously created or choose any dataset, so it's showing me blank. And this is my train model which I've trained and which is working properly on a sensor based income dataset. Okay, so like this as your machine learning studio work. And you have also create your experiment by clicking here new. And then you can also see here many list of experiment like download data set from uci dataset. And it's a data set processing and analysis and auto import regression. Like this model is basically work upon regression. And this is binary classification and validation. So there are various type of a huge list of k-mean clustering and various type of experiment list on which you can work upon. So just for showing, I have to k-mean clustering open in Studio Classic. Okay, so we can easily understand how things are going to happen. Yeah, so it's basically its name is clustering, which is group iris dataset. We hear about the what is iris dataset. Iris dataset is basically flower and petal length and width type of dataset, which is just tell about the length and width of a petal of iris flower. When contain module and dataset which have newer version, please wait your experiment is upgraded. Okay, so we have to just you can see the model or workflow here. Okay, how things is going. Like first of all, you have to import data. You can easily read data directly from UCI repository. And then clean missing data. Like what is this step is going to done, that missing data is which data have a null value. That data on this type of data model not to work properly. Then have edit metadata. Okay, you can also edit metadata, like you have to change the column name. And also you can by your own add some input data in that column. Then we have k-mean clustering algo. And this is a multi-class logistic regression. And this is our split data. So it's a basic workflow which we have to follow in every project. And then we have trained clustering model. And then we have trained this model. So basically there are two models that is showing to us. And then you can also zoom this up this and assign to cluster. And it's basically a workflow is going to upon you that what thing are you are going to you want to use in your project. Okay, select column in data set. It's also select column in data set, but it is selecting column data set to the train model, but it is selecting a model to the assigned to the cluster. Which it's basically clustering algorithm which make a cluster in our data set. Cluster, like say we can say cluster is like a group. we can group our data sets, like this is from group 1, this is from group 2, like this. And this machine we can also run this and see that it's working properly or not. So in right panel we can see that. That's showing running. So as large your data set, meanwhile as more time are this run feature take, like it's directly proportional to data set data set length and width. We can say volume of data set. So it's take 54 second, because we have so it's showing a status code finished, which is which means that our data set is I mean our project is the drag and drop feature. And how we can connect, like if you connect them properly, you can see that there is a green right tick on this boxes. It will show that you are working like properly, your flow is correct, and there is no any type of error. if is there any type of error, this is so a red question mark, from which we can easily understand that are not working properly or we have to add up some value. So like this Microsoft machine learning studio work, it's like for a beginner who want to understand the machine learning, like what's happen, how model work, how connected, and then what model give us, like we have give to model as an input or data set, like, and then what model can do on that data set and give it to us, we can easily understand and also predict our value, our feature which we want to ask to that project. Thank you.
Yeah, hello, Pratap.
There. So we have some. Yeah. So are you already given some answers for this one?
Yeah, there are two more queries.
Yeah.
So for the I am seeing here, like, may I know what is the purpose of Azure
Mm,
ML? So I have answered it. The next one
okay.
is by Monica. So what are some of the benefits of using the managed services? Okay.
Yes. Yeah.
So
Yeah.
to talk about the benefits, like the we can the speed as well as the efficiency, the reduced complexities, cost effectiveness, scalability, the built-in governance, as well as the compliance. Like many Azure ML platform includes features for managing the data privacy, security, and regulatory compliance, which can be also used for the crucial organizations operating in a regulated industry or handling sensitive data. To talk about the speed and efficiency, you can say that Azure machine learning platform automates the tedious and time-consuming tasks involved in machine learning lifecycle, such as feature engineering, model selection, hyperparameter tuning, deployment, etc. So, and also it it often incorporates the best practice for model development and deployment, resulting in more robust and reliable machine learning solutions as compared to the traditional machine learning development processes. So they may also provide monitoring and altering capabilities to detect and address issue. And one of
Yeah.
the main advantage is
So
about, yeah.
yes, please. Yes, please. 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 Carry on.
Yeah, and another advantage is about the integration with the existing systems. Like Azure machine learning platforms are typically designed to integrate with the existing data infrastructure and tools, making it easier to incorporate the machine learning into existing workflows as well as applications. So these are few advantages of
Oh.
Azure machine learning over traditional machine learning process. And here I
Okay.
can
Okay.
see one more query. Like, can you guys explain about the prompt flow in Azure machine learning? Oh, okay. So the prompt flow, it provides a user-friendly and drag and drop interface for building machine learning pipelines. Like the users can visually construct their pipelines by selecting a variety of pre-built components and connecting them together. The another feature we can say that about a customization, like a prompt flow, it allows the user to customize the machine learning pipelines by selecting specific algorithms, data processing techniques, feature engineering methods, and evaluation metrics. This level of customization also enables the user to tailor the pipelines into the specific requirement of the machine learning task. Then the guided experience, we can say, like it guides the user through the process of building machine learning pipelines step by step, providing the explanations, recommendations along the way of the building process. It also guides the experience, help users to navigate the complexities of the machine learning, and making to enable them to make more informed decisions at each stage of the pipeline. Also, it provides automation, like which enables the user to customize the machine learning pipelines, and it also includes the tasks such as data preprocessing, feature selection, hyperparameter tuning, model training, model evaluation, and also seamlessly integrate with other Azure ML services, allowing the users to leverage the additional capabilities such as data storage, model deployment, monitoring, etc. And also ch- we can say that a machine learning pipeline has been created using which has been created using prompt flow. It can be saved and reused for the further product projects, or shared with other users within the organization. So it
Yes.
prompts the collaboration and accelerates the development of machine learning solution. So overall, it provides a user-friendly and efficient way to build, customize, and deploy machine learning pipelines, making it easier for the user to power the machine learning models and into the data-driven applications.
Yeah, of course I do. Even though, so whenever I want to integrate any some Hugging Face models or else any like, so we have some model catalog models are there. On that time also it will make sense regarding this one as well. And
Yeah,
and one more thing is that, so I saw some of the features in the machine learning and as well as the Azure AI Studio are the similar. I think so some of the inbuilt features, like for example the model catalog models, the model catalog, I think I didn't remember anything, model catalog and as well as the um is the prompt engineering. So the prompt engineering that plays a key role in the while we are creating any LLM models. So it will play a key role on the times of the prompt flows will play a key role. So whenever we need to integrate the particular best prompts to the our LLM model, so then we get the some outstanding responses from this LLM model. So in that case, so this prompt flow plays a key role. And moreover this model catalog, so we have the all the models, so like the llama models and some so Hugging Face models and whisper models and everything that will be inbuilt, and it will be plays a key role in this particular machine learning models and as well as these. So recently I saw some features in this Azure AI Studio, I think. So this Azure AI Studio and machine learning is some so whatever the AI content features, so everything that will be integrated in the Azure AI Studio. I think probably it will move to this AI Studio. Yeah, that's all for
yeah,
me. And I don't have the much questions regarding this session. So I think everyone is enjoyed. I think probably in the Twitter it more than lot of people are joined, I think, compared to LinkedIn. Yeah, thank you Sakshi and take for your valuable session, and Kushbu, thank you so much for your
yeah.
session.
Thank you for providing us this opportunity.
Yeah, yeah. No, anytime, anytime. So I'm there for this community events as well.
Yes,
Yeah,
thank you, Pratap.
Yeah,
thank you. No issues, Kushbu. So I would like to end the stream. And Sakshi, you are please be on 1 second. Please stay here.
yeah.